I'm Alex Polvi, CEO and co-founder of CoreOS, although I'm most famously known for being the creator of the OpenStack meetup here in the Bay Area. And I got involved with OpenStack actually pretty early on after my previous company, CloudKick, was acquired by Rackspace. And just a little bit of trivia. I'm not going to all claim that I invented OpenStack. No, I'm not by any means. But right after Rackspace had acquired SliceHost, I did mention to Rackspace leadership once that they should open source SliceHost and give that out to the world. So I don't know if it had something to do with it, but maybe that's what led to eventually OpenStack. So, all right. I'm going to give you a quick little overview of CoreOS and then talk about a couple myths that we've been seeing companies run into and sort of debunk some of these myths. So first, talk about CoreOS and why we're building what we're building. Like all startups in Silicon Valley, our company was born in a garage in Palo Alto. You see it here. We were actually part of the Y Combinator process, which pitched CoreOS a little over 2 years ago on this stage. Y Combinator's demo days are at this place right here. There's now at this point, there's like 100 companies that go doing these 3-minute pitches or something. It's crazy. But I was pitching right here, so I feel like I should go into pitch mode. Maybe there's some VCs in the room. So why did we start building CoreOS? So we started building CoreOS around this idea of what could we do to fundamentally improve the security of the internet? Seems like a good mission, and if it works, it seems like there's a big business around that. And if the way we approached it and our insight is that the key to good security is actually about updates. It's the ability for companies to quickly update their software, both their operating system, as we do with CoreOS Linux, but also the applications that run on top of it. And they have to be able to update their software in such a way that even if they deploy a bad update, things are OK. So the real true solution to security on the web, the biggest piece that we observed is really just around running the latest version of your software. And the reason that server infrastructure is getting hacked all the time is because everybody's server infrastructure is just so fragile, people are afraid to update and change things. In fact, the way we think about our servers are get it running and don't touch it. So we thought, hey, let's try to address this all the way down to its core level. No pun intended. So what does it look like? What does this server infrastructure look like if we want to design essentially the most ideal thing? Well, we've actually seen it before. What it looks like is what we've seen the hyperscale guys do. And it's this model that involves distributed systems. It involves containers. It involves often standard hardware on large server deployments, but cloud infrastructure works just the same. And we've been calling it Giphy, because no better term existed, Google's infrastructure for everyone else. I think now we're supposed to be calling it Cloud Native after the Cloud Native Foundation. But it's this model of running infrastructure where you treat your environment as this big pool of resources, and you focus on applications, not individual servers. A number of these projects like Mesos and Kubernetes, Swarm, and these things we've been talking about really are focusing on at that level. And so we started building kind of everything required to do this. Our first 2 projects that we released were CoreOS Linux, our Linux distribution. CoreOS Linux created a category around this lightweight container OS. And then we created etcd, which is a distributed data store and the underpinning of building any sort of distributed system. You need this data store that's highly available and consistent. So I thought it was pretty cool. As like a 5-person startup, the first 2 products we ship are a new Linux OS and a distributed database. Give it to the team for that one. But since then, we've developed over 90 projects on GitHub. And then we've also put together an offering for companies that want just help getting going in this infrastructure, and that's Tectonic. So Tectonic is, if you want your own Giphy, just in a box and you can get going, that's what it is. It's based around Kubernetes. As we're building Google's infrastructure for everyone else, it was great to be able to partner up with Google on that. Google Ventures is also invested in us. And I don't want to get too much into the sales pitch here, but you get the idea. It's a full stack deployment of how you run your own Google-like infrastructure. And for our motivations in all of this are, if you do it this way, give you a lot of benefits from running your infrastructure this way, high availability, resiliency, failover, utilization. But we also think we can give you an edge on security. We can do some really interesting things around helping you automatically patch your infrastructure and keep things up to date in a way that you couldn't do if you weren't running your infrastructure this way. OK? So that's what we are all about. Now I'm going to jump into some of the things that we've seen companies running into and some of the myths that we've been running into, or maybe they're better, I should have put memes up there, that are confusing these bigger guys as we run into them. So I want to just talk through, I have 4 of them, and we can just go through them one by one. The first one is that containers replace VMs. And again, myth number 1, meaning they don't. So let's talk about this. What is a VM? I think that this is I put this up there and I'm like, I go into the OpenStack thing, put in a slide that says, what is a VM? But I just wanted to frame it here for a moment. So a virtual machine takes a big server and it carves it up into lots of little servers. Right? That's kind of the essence of the whole thing. It's really useful for multi-tenant deployments where you want to do that. Your multi-tenancy could either be a public cloud service or for companies that are so big they just have a lot of OS diversity. They need kind of different platforms to run in their own environment. Okay? That makes sense? Everyone agree? That's kind of what VM is. All right. When we're talking about this containers and cloud native thing, we're actually thinking about it the opposite way. We want to take a bunch of servers and make them appear as one big computer. So this is a bit confusing because, a container, that logical unit of executing a process, yes, that's not really in line with that. But all of this work that's going on around Kubernetes and Swarm and everything, I really think that's the essence of what's going on with containers right now. Yes, there's that little logical unit inside of it, but as you'll notice, every single vendor in this space is working towards that bigger vision of this distributed platform. And that's the piece that is take an arbitrary size set of servers and treat them as one big pool of capacity, one data center as the computer style piece of compute, almost bringing it back to the mainframe days, but done over complete commodity, fungible hardware underneath. So when you look at it from this perspective, a VM is just a unit of compute resources in order to do that. So when we put, for instance, Tectonic on top of OpenStack, that's because we are using the OpenStack Nova-based virtual machines in order to provide the resources to the cluster management systems that are running on top of it. At this point, in 2015, AWS can print servers for businesses, or Dell can print servers for businesses, or companies can have these own mechanisms for creating servers on demand in their own environments with things like OpenStack. And at the end of the day, this model just treats virtual machines or bare metal as the same, but it's a bit orthogonal to the virtual machine in and of itself. So that's number 1. OK, second big meme going around. Legacy apps do not work in this model. So I did some hardcore market research on this one. Here's my market research. I've just been, I'm a pretty technical guy, so I've been trying to understand actually what is it about these legacy apps that doesn't work in containers? Because it's been this thing going around, and I actually just hadn't studied enough to understand, like, what are people even talking about when they mean legacy apps? So, I put it out to the Clouderati to see what's going on. First response back, Mark Carter. Mark, are you here, by the way? No? OK. Anyway? No? All right. Mark, SAP, Oracle, like, OK, I kind of get it. Yeah, at the end of the day, though, without violating NDAs, we'll let the next person go. Actually, there's a blog post that says that Oracle is running on top of inside of containers. And for SAP workloads that can go on top of Linux, technically, there's no reason that can go on there as well. So I guess kind of, but I think if we dug deep, we could actually put SAP and Oracle inside of containers. Again, on top of a Linux host, no problem. On top of a Windows host, it might be a little trickier, but it's doable. So let's go to the next one. SharePoint, Microsoft Word. OK, guys, you kind of got us on this one, but this is really about running Windows on top of these distributed container things. And we've already seen Microsoft start making pretty heavy investments in this space. So I'm sure it's only a matter of time. From our point of view, we think that Linux is the ideal sort of base OS for these big distributed data center workloads. I did Google to see if I could figure out a way to get SharePoint running on Linux. Unfortunately, there weren't a lot of resources out there for that. So this is one where it doesn't work, meaning legacy apps, if you want to run Linux, or you want to run Windows apps inside of a Linux container, not really doable right now. But I think that's kind of missing the point a little bit. And then the last one here that we got was all things with data in them, which takes me to my second to last one. You can only run stateless apps. OK, so this is another meme that's definitely been rolling around in this space a lot, that you can only run stateless things in your container distributed systems workload. And let's talk about that for a second. So no matter what happens, you need to manage state, whether it's with containers or not. I believe that everything in your data center is eventually stateless. You will eventually have a stateless data center. It's just about how resilient do you want to make it. That's why we do things like database backups. That's why we put stuff on tapes and ship them off to the mountains in Virginia. It's because we believe at some point our data centers will go stateless. And you have to manage state and replication and backups some way, just like you do in your non-containerized, non-workload, non-distributed systems world. This problem doesn't go away with either. It's just how you approach it is slightly different. So how do we manage it today? I mean, the most common approach is that first one. Just write it to disk, hope everything works out, and back it up maybe. You get more sophisticated when you start bringing in these network devices, using things like RAID controllers to push that replication into actual hardware devices for you. So at least you can lose particular hard drives and do it that way. And then you get into these more advanced solutions, things that actually use distributed systems, but to present stateful data on top of it, things like EBS, Ceph, or completely different paradigms for how you do storage, such as an S3, which is its own unique thing. All of these apply to containers in this cloud-native world. If you, for instance, have your application, your container write to its local disk, at some point that will go away. So you have to write an application that either backs it up, or you have to do something, or you can choose to use something like a Swift or an S3 to store it, just like you would in your non-containerized workload. All right, and the last one, which I've actually done quite a bit of work on this one, is around security. So first, as a company that's trying to secure the internet, I'm really glad that how much scrutiny that this one has gotten. So I think that containers aren't the final solution, but they are a step forward. Okay, so what we had before all of this worked is we had the ops guy bin packing, and what that means is the ops guy, through things like Chef and Puppet, or just by manual with a spreadsheet, decides where applications should run. And for the most part, if the database and the web app can run on the same machine because the workload or the I/O on both is balanced, then that's OK, and you can go and do that. And the way that it happens from a security perspective is that if your web app gets hacked, anything that gets compromised on that machine or anything that's on the same machine as that app that got compromised, everything is now owned on that box. While containers aren't perfect at this, they are another layer. When your single container that gets hacked on that machine goes, the attacker has a smaller view of the world than they would get on a normal server. Now again, yes, there are arguments that they can work out around that, so on, but it is another layer. So even from what we have today and the way that things are architected with the tools that we have today is slightly better, if not, I don't know, I'd say meaningfully better than just the previous model, which is run all the applications you want on one box and hope for the best. The only thing that would be better than this model overall is if you are only running one application per server or VM. That would beat doing it multiple applications inside of containers today. And companies, they're very, very likely companies doing that today. It's likely for the larger workload guys that are doing big deployments. At the smaller scale, we're seeing lots of people still spray their random applications across the one instance. So just to recap here, the things that we keep running into are containers are replacing virtual machines. No, containers consume compute. Virtual machines are a way to provide compute. Legacy applications don't work. Again, if you guys have a legacy application that works on Linux that doesn't work in containers, please, please, please talk to me or tweet at me about this. I'd love to figure it out. I need to understand this, and I just can't figure it out for the life of me, what applications everyone's talking about when they're saying legacy apps. And as far as I can tell, it's all very possible. You can only run stateless applications. Again, you still have to manage state, just like you had to manage state in the non-containerized world. Things don't fundamentally change there. and then containers are not secure. And some of the work that we're doing around containers in particular are going above and beyond. For instance, with Rocket this past week, we shipped Rocket is our container runtime. We shipped a partnership with Intel, a popular theme for today, where we're executing the container transparently inside of a virtual machine without the user having any intervention. It's just a flag you put on there. You go Rocket run, etcd, or you go Rocket run -- virtual machine etcd, and etcd is executing inside of a fully isolated VM with minimal performance overhead. And those sorts of things become possible, and we'll continue to push on those sorts of features to make it as secure as possible. So, in closing, we as a company are using this cloud native, Google's infrastructure for everyone else to fundamentally improve the security of the internet. On the developer side, you should check out our open source, either on CoreOS.com or our GitHub has lots of stuff going on there. And businesses that are interested in running this style of infrastructure should check out our commercial offerings at tectonic.com. That's all. Thank you so much.